27 million pounds. Say it slowly, and it still refuses to mean anything. That is not a ship. That is not a building. That is one single machine, standing on two flat steel feet in a cornfield in southeastern Ohio, and it took 200,000 man-hours just to get it standing upright. May of 1969, near a bend in the Muskingum River, they woke this thing up for the first time. 22 stories of black lattice steel groaned, shifted its weight, and took one step. 12 feet, 10 seconds. That single step burned more electricity than half the houses in the county, running at once. Men who had built battleships during the war stood at the fence and watched a machine move like nothing they had ever built before, and felt small doing it. This is Big Muskie, a bucket big enough to park 2 Greyhound buses side by side, a boom the length of a football field. It did not dig so much as it reached out across a hillside, sank its jaws into 300 tons of Ohio rock, and hauled the load back toward itself, the way something enormous and unhurried pulls its dinner closer. Here is the part almost nobody tells you. The exact numbers that made this machine a miracle in 1969 are the same numbers that killed it. The size that let it eat a hillside a week is the size that made it too expensive to feed, too slow to reposition, too heavy to sell, and eventually too dangerous to keep standing once the money stopped coming in. 200,000 man-hours went into building this thing. Less than 30 years later, a torch crew needed a few months to turn it into $700,000 of scrap, and one lonely steel bucket sitting in a field. That gap, between what it cost to build and what it was worth when they killed it, is the whole story. How do you build something almost too big to exist? And how does being almost too big to exist end up being exactly what kills you? Stick with this one, because we are not just going to marvel at the size of the thing. We are going to watch that exact same size turn on itself, 22 years later. How does a machine built to outlast generations end up not even outlasting the men who built it? 27 million pounds of almost impossible. It killed the household budget of an entire county every single hour it ran, and nobody who built it thought that would be the problem. Start with the weight. 27 million pounds, heavier than the Eiffel Tower, with enough steel left over to build a second one and still have scrap to spare. It stood 222 feet tall, nearly 22 stories, visible from ridgelines a county away, and it never once left the property it was born on, because nothing on earth could move it once it was whole. It cost $25 million in 1969. Adjusted for what a dollar is worth now, that is north of 200 million, spent on a single piece of equipment that could not be driven down a highway, could not be loaded onto a ship, and could not be sold to anyone who did not happen to own a mine shaped exactly like the one it was built for. It swallowed 220 cubic yards in a single pull, somewhere close to 300 tons of dirt, shale, and sandstone gone in one bite, lifted 100 feet in the air, and dropped 2 city blocks away, less like excavation and more like something enormous feeding. It drank 13,800 volts through a cable as thick as a man's forearm, and it drew enough current, every hour it worked, to light 27,500 homes. The company that owned it had to sign special agreements with local power companies just to keep the lights on in the rest of the county while this thing was awake. And for all that power, all that appetite, it crawled, 1/10 of a mile an hour. A grown man walking backward could stay ahead of it without breaking a sweat. Each step covered about 12 feet and took most of 10 seconds, and that was considered fast for a machine this size. Slow did not mean gentle. In a single working hour, this thing could move close to 39 million pounds of earth and rock. Across 22 years on the job, it moved more than 600 million cubic yards of overburden, roughly double what it took to dig the entire Panama Canal. And it did that from a fixed patch of ground in one county in Ohio, never traveling more than a few thousand feet from where it was born. It never slept either. 7 men at a time, 4 separate crews rotating in shifts, kept it running around the clock, 364 days a year, stopping only for Christmas. A machine that size does not get weekends. It gets an operator, 2 oilers, 2 dozer men, a welder, and an electrician, standing watch in every kind of Ohio weather, because the one thing more expensive than running this machine was letting it sit idle. And this was not a design Bucyrus Erie could simply order up copies of once the pattern existed. The 4250W was built once, to one customer's specifications, for one mine, and it was never built again. No sister machine, no production run, no second unit to spread that $25 million price tag across multiple buyers. Every risk in the design belonged entirely to this one machine, with nothing to fall back on if any part of it failed to work as promised. None of that is the strangest number. The strangest number is 200,000. That is how many man-hours it took to build this thing, over roughly 2 years, using 340 railcars and 260 trucks just to haul the pieces to a muddy field in Muskingum County, because there was no factory floor on the planet big enough to assemble it under one roof. Men built this machine outdoors, in Ohio winters, piece by piece, for 2 straight years. That is the fact this whole story is built around. We will come back to exactly how you build something that size, with nothing but hand tools, cranes, and 200,000 hours of human labor. Keep that number in your head. It is the reason this video exists. Here is where it gets almost impossible to believe. After 22 years of eating Ohio hillsides around the clock, after outliving 3 different presidents' worth of coal policy, Big Muskie sat dead and silent for 8 straight years. Nobody wanted it. Nobody could afford to move it. And in 1999, a crew showed up with cutting torches and turned 200,000 man-hours of 1960s American engineering into $700,000 of scrap steel, less than 3% of what it cost to build in the first place. A machine built to last generations, gone in a season, for less money than it took to ship the bolts. How does something that big, that expensive, that record-setting, end up worth less than the truck that hauled its bucket away? That is the question this whole video is chasing. And the answer starts, like most disasters do, with a company that had a very good reason to build something this ridiculous in the first place. The mountain that wouldn't move. Central Ohio Coal Company had a problem no ordinary machine could solve, and the problem was buried under 150 feet of rock. By the mid-1960s, Central Ohio Coal, a division of American Electric Power, controlled 110,000 acres of hilly southeastern Ohio, and underneath that hilly ground sat brown coal, the high-sulfur kind, the kind Ohio had in abundance. But it was not sitting there waiting to be scooped up. The seams ran anywhere from 18 inches to 4 feet thick, buried under as much as 150 feet of sandstone, shale, and clay, folded across land that rolled and dipped instead of lying flat. A standard power shovel digs from below, driving into the ground it is standing on terrain this uneven, that is slow and it is dangerous, because the machine has to work its way down into unstable footing to reach rock it cannot see the shape of until it is already committed. AEP needed something that could stand on solid, already stripped ground, reach out over the hillside, and pull the overburden clear without ever having to drive into the mess it was creating. That meant a dragline, not a shovel, a machine that dug from a distance, the way you might use a rake instead of your own 2 hands, to clear a fire pit you did not trust. There was a second reason, one that had nothing to do with getting coal out and everything to do with what came after. AEP wanted the stripped land usable again once the coal was gone, and a dragline working at a distance could lay overburden back down in a pattern that made regrading and replanting realistic, where a shovel churning across the same ground left something closer to a wreck. Central Ohio Coal was already thinking about the land it would have to hand back, even while it was still solving how to tear that land open in the first place. Bucyrus Erie was not the only company capable of building something this large. Marion Power Shovel, a few hundred miles west, was chasing its own record-setting stripping shovel around the same years, a machine that would earn the nickname the Captain. But AEP's ground was a dragline problem, not a shovel problem, and that put the contract squarely in Bucyrus Erie's hands, with no real rival bidding for the job. But the volume AEP needed was not a normal dragline job either. The company was burning through coal at a rate that outpaced anything the existing machines in Ohio could keep up with, and the terrain made every acre expensive to strip with equipment built for flat prairie mining out west. So in 1966, AEP went looking for someone who could build a dragline unlike anything that had ever been ordered before, and they found Bucyrus Erie, a company out of South Milwaukee, Wisconsin, that had spent decades building the machines that moved mountains for the Panama Canal and half the strip mines in the Midwest. There was a bigger current running underneath all of this too. 1966 sat in the middle of a stretch of American history where electricity demand was climbing faster than almost anyone had planned for. Air conditioners and televisions and factories all pulling harder on the grid every single year. The record was almost beside the point. AEP built this machine to keep pace with a demand curve that showed no sign of leveling off, and cheap Ohio coal, however deep and however awkward to reach, was the fuel that curve depended on. Bucyrus Erie had built big before. They had never built this big. The contract called for a single bucket machine that could outdig every dragline in existence, that could stand on ground too soft and too steep for a conventional excavator, and that could keep working 24 hours a day without needing to be relocated every few hours the way smaller machines did. That contract also settles a strange fact from a few minutes ago: why a machine this record-breaking never got a sister unit. Bucyrus Erie built this to answer one company's exact hillside in one county with coal buried at one specific depth, not to sell the design twice. A machine engineered that precisely to a single customer's terrain was never going to roll off a line and find a second buyer. That was the whole nature of the deal, settled the moment the ink dried in 1966. Somewhere in the engineering meetings at South Milwaukee, somebody had to answer a question that sounds almost comical until you understand the stakes. How do you build a machine so heavy that ordinary crawler tracks would sink it into its own pit? The answer they landed on would define everything about how this machine moved for the rest of its life, and it is the reason a machine that could tear a hillside apart in one bite could barely outpace a man on foot. We will get to exactly how that worked. For now, understand this. By the time the ink dried on that contract in 1966, Central Ohio Coal Company had committed itself to building something that no crane, no highway, and no single factory could ever move whole. Everything that came after, every dollar, every debt, every year this thing sat idle waiting to die, traces back to that one decision. 2 years, 200,000 hours, one machine. Nobody builds a 27 million pound machine. They build it in pieces and pray the pieces still agree with each other in the mud. Bucyrus Erie's engineers had already answered the weight problem the only way that made sense. Ordinary crawler tracks concentrate a machine's full weight onto narrow steel bands, and on a structure this heavy, that pressure would have driven the machine straight down into its own footing, sinking it inches with every pass. Instead, they built Big Muskie 2 enormous hydraulic feet, called shoes, each one weighing 3,200 pounds on its own. To move, the machine lifted its entire 27 million pound body a few inches off the ground on those shoes, shuffled forward roughly 12 feet, and set itself back down, spreading that impossible weight across a footprint wide enough that the ground beneath it could actually hold. It looked less like walking and more like something enormous learning to crawl for the first time, one deliberate motion at a time, and it explains the 1/10 of a mile an hour top speed from Chapter 1. That crawl was never a flaw in the design. It was the design. The alternative was a machine that sank. The digging end of the machine ran on pure electric muscle, because nothing else could deliver power at this scale reliably, hour after hour, for decades. 18 electric motors rated at 1,000 horsepower apiece, another 10 rated at 625 horsepower, all wired into a chain that pulled somewhere north of 50,000 horsepower at peak load, fed by that 13,800-volt cable running back to the grid. Fire the drag cable, and the bucket bit into the hillside. Haul it back, and 300 tons of Ohio earth came with it, hoisted skyward on cables strong enough to lift a locomotive, swung out over the spoil bank, and dumped in a controlled avalanche 2 city blocks from where it started. Every part of that chain, the motors, the cables, the drums, the twin 310-foot booms holding the whole operation aloft, existed to answer one obstacle: a hillside that would not give up its coal without a fight, measured in tons per minute. The boom itself was its own puzzle. At 310 feet, it could not be cast or shipped as one piece, so Bucyrus Erie built it as 2 lattice sections married together at the point sheave near the tip, pinned and welded to carry the strain of swinging 300 tons on a lever the length of a football field. Get that joint slightly wrong, and the boom becomes the fulcrum for a catastrophe instead of a tool. Get it right, and you have built the longest reach any digging machine on the planet has ever swung. But the engineering was never the hard part. The hard part was getting all of it, in one piece, to a muddy hillside in Muskingum County. A machine this size could not be built on a factory floor and shipped whole, because there was no road, no rail line, and no ship built to carry something this enormous in one load. So Bucyrus Erie built Big Muskie the only way it could be built: in fragments. Steel plate, gearing, motor housings, boom lattice sections, cast in South Milwaukee and loaded onto 340 separate rail cars and 260 separate trucks, shipped east to a construction site that had, at the start, nothing on it but graded ground and a survey crew's stakes. Then the real work began. For roughly 2 years, crews of welders, riggers, and electricians worked outdoors, through Ohio summers and Ohio winters, bolting and welding this machine together directly on the site where it would spend its entire working life, because it would never be moved again once it stood up. There was no roof over their heads and no factory walls around them. The factory, in every sense that mattered, was the open field itself, and the machine grew a little larger every week as more railcars arrived. You do not start building something like this at the top. So how do you even begin stacking 27 million pounds of steel in an open field? Crews laid the base and the 2 hydraulic walking shoes first, because everything that came later would depend entirely on how well that foundation held under load. Only once that platform could bear real weight did the revolving upperworks go on top of it, the housing that would carry the operator's cab, and the massive drums that spooled the drag and hoist cables. Only after that did the twin boom sections rise, hoisted into place by mobile cranes that were themselves enormous machines, groaning under loads that would have been unthinkable on almost any other job site in the country. Every stage depended entirely on the one beneath it holding true. There was no discovering a mistake 3 stories up and simply fixing it later. It had to be right the first time, in Ohio mud, in Ohio winter, with nothing overhead but sky. Ohio winter was not a small detail to work around. Cold steel behaves differently under a welding torch than warm steel does, shrinking and cracking in ways that demanded patience most job sites never ask for, and crews still had to keep pace with a 2-year schedule regardless of what the sky was doing that week. Riggers worked gloved hands around cable clamps in temperatures that made every bolt a small negotiation with the weather. Nobody paused the project for a bad month. There were not enough months in the contract to spare one. By the time it was finished, the crews had logged more than 200,000 man-hours, the exact number from Chapter 1, spread across engineers who had designed nothing this large before, and iron workers who learned the machine's anatomy joint by joint, because there was no other way to learn it. That is the debt this video opened with, and that is how it gets paid. Not in one factory, but in a field, over 2 winters, by men whose names mostly never made it into any record at all. On May 22, 1969, they finished. And before Big Muskie ever took a working bite out of Ohio, the company held a dedication ceremony at the mine site. Photographs from that day survive, and one of them says more than any spec sheet could. The entire Morgan High School marching band stood in formation inside Big Muskie's empty bucket, in full uniform, packed shoulder to shoulder, inside a steel scoop built to swallow 300 tons of rock, smiling for a photograph that made the front page of papers across the region. For one afternoon, before this machine had moved a single ounce of overburden, it was pure civic pride. A monument to what American industry could still build when it decided to build something absurd on purpose. Nobody in that bucket that day was thinking about electricity bills or federal emissions law. They were thinking about a hometown machine that had just become the biggest thing any of them would ever stand inside. A few weeks later, the real test came, with no band and no cameras waiting for a triumphant shot. The operator settled into the cab, ran the drag cable out across untouched hillside for the very first time, and hauled back on the controls. 220 cubic yards of Ohio rock tore loose from the earth in one continuous pull, swung out over open ground on cables built to lift a locomotive, and dropped in a cloud of dust the crew could feel through the steel under their boots. Nothing failed. No gear stripped. No cable snapped. No shoe sank into ground it was never meant to hold. The machine that 2 years and 200,000 hours had promised into existence did exactly what those 2 years had promised it would do. It ate. That quiet was not going to last. A machine built at this scale does not sit still and admire itself. It goes to work, and work, for something this size, comes with a bill that grows heavier every single hour the motors run. The cost of running a monster. It took 7 men to keep a 27 million pound machine breathing, and none of them got Christmas Eve off unless the phone happened not to ring. Picture standing on that same patch of ground today, though. No boom overhead, no cable feeding 13,800 volts into a machine that could swallow a 2-story house in one pull. Just quiet, reclaimed pasture, and if you know exactly where to look, a single steel bucket sitting alone in a field. That collapse is still 2 decades away from where the story stands right now. But hold on to that image, because every dollar this machine is about to burn, every ton it moves, every year it grinds through starting now, is quietly building toward that same empty field. Big Muskie ran 24 hours a day, 364 days a year, stopping only for 30-minute meal breaks, mechanical emergencies, and Christmas. One operator sat at the controls, working the drag and hoist levers with the kind of focus a machine this unforgiving demands. 2 oilers crawled the structure constantly, greasing bearings and checking cable wear, because a single seized bearing on a machine drawing 50,000 horsepower could sideline the operation for days. 2 dozer men shaped the ground around it. A welder and an electrician stood ready for whatever broke, because on a machine this size, something was always threatening to break. So what actually happened when something failed? Every bearing, gear, and motor winding on this machine lived under strain that never let up, and keeping it alive was its own around-the-clock war fought in grease and cold hands. One company man named Reed spent years on the Big Muskie crew doing whatever the job called for that day, running bulldozers, pumping water out of pit ponds, climbing the 330-foot twin booms whenever the machine shut down for the night to check every joint by hand. Make sure the lines were greasing and there were no broken lines, he said, and everything was getting properly lubed so you would not have a bearing go out. That was the entire game, not glamour. A constant, grinding fight against friction, on a machine where one neglected bearing could cost the company a full day of downtime, at tens of thousands of dollars an hour, for a repair that started with something as small as a dry seal nobody caught in time. Dave Bailey worked as one of those electricians for a decade, keeping the wiring and the motor systems alive through some of the machine's hardest years. By his own reckoning, running Big Muskie took something close to 2/3 the power draw of Las Vegas. Not a small town's worth of electricity, but a real slice of an entire city built to burn it without apology, pulled through a single trailing cable every hour the machine operated. That power did not come cheap, and it did not come free of consequences. Running Big Muskie cost the company tens of thousands of dollars an hour in electricity alone, a bill so large that Central Ohio Coal had to negotiate special rate agreements with local utilities just to keep the surrounding towns supplied while the dragline was awake. Even feeding the machine its power was its own fight. That 13,800-volt line ran through a heavy trailing cable, and because the machine never stopped relocating a few feet at a time, the cable needed its own dedicated transporter and coiling unit just to keep pace, reeling out slack when the dragline walked forward, and taking it back up when it walked back. Snag that cable under a shifting load, and you were not looking at a blown fuse. You were looking at a line carrying enough voltage to stop a heart, lying exposed on ground the machine itself had just torn open. Crews leaned hard into night shifts whenever they could, because the price per kilowatt-hour dropped after dark, and a machine burning this much power could not afford to ignore a discount. Bailey remembered the rhythm of it without complaint, a crew that worked 364 days a year, off only Christmas, trained and federally certified for a job that never really let a man go once he started it. Speed was the other tax nobody budgeted for. A machine capable of stripping 8,000 cubic yards of overburden an hour still had to occasionally pick up its own 27 million pounds and relocate, and at 1/10 of a mile an hour, that relocation could swallow the better part of a shift. Operators learned to plan their moves the way a chess player plans 3 turns ahead, because repositioning this machine was not something you could improvise. Every wasted step cost real money, on a machine already burning cash simply by existing. Then there was the ground itself, always a threat. Big Muskie worked at the edge of high walls cut 50 to 70 meters into sandstone and shale, rock faces exposed by the very stripping the machine existed to perform. Across the mining industry, high wall failures account for a real share of surface mine deaths every year, and the warning signs an operator gets, hairline cracks at the crest, a faint creaking underfoot, are not always enough to outrun a slope that decides to let go. Big Muskie's crew lived at that edge nearly every day, trusting inspections, trusting each other, and trusting that the rock they had just exposed would hold. The machine's appetite did not stop at rock and coal. Every week it worked. Big Muskie rearranged the surface of Muskingum County a little more permanently, turning rolling Appalachian hardwood ridges into terraced gray spoil banks that stretched for acres, ground down to bare rock, in places nothing smaller could have reached before. Across 22 years, it laid open more than 110,000 acres of hill country to uncover 20 million tons of coal, and it left behind a landscape that no longer resembled the one it started with. A machine capable of feeding an entire regional grid was, underneath everything else, still just an enormous scar-making tool, and every man on that crew knew exactly what that scar looked like from inside the cab. Not every night on that mine was danger and arithmetic. Shannon Markin's father worked as a lead mechanic on Big Muskie for more than 4 years, and one memory she carries is quieter than any of the numbers. It was Christmas Eve, after dark, close to 8 at night, when the phone rang with a hydraulic line that needed fixing out at the strip mine. He asked his kids if they wanted to come along. They rode out together into the cold and the dark, past the shape of a machine 22 stories tall, standing silent under work lights, while her father climbed up into it to make the repair. For a company that never closed except one day a year, that was what devotion to the job actually looked like up close. Not heroics. A father, his children in the truck, and a hydraulic line that would not fix itself. All of it, The crew, the power bill, the crawl, the ground underfoot was survivable as long as the coal it uncovered was worth what it cost to reach. That balance had held for years. It was not going to hold forever. The numbers turn on the beast. Coal was the one thing Big Muskie could not control, and coal was about to turn against it. The seams this machine had been built to expose were high-sulfur brown coal, cheap and abundant across southeastern Ohio, and exactly the fuel American power plants had leaned on for decades. Then the rules around burning it started tightening. The Clean Air Act, first passed in 1970 and strengthened again in 1977, put growing pressure on high-sulfur emissions, and utilities across the country began shifting toward cleaner burning coal from western states, and eventually toward natural gas. Every year that pressure grew, the coal sitting under Big Muskie's feet got a little less valuable, even as the cost of digging it out kept climbing. By 1982, the public had noticed the strain, even if they framed it as spectacle rather than economics. A regional newspaper ran a headline that captured the mood better than any balance sheet could. Caverns yawn as Big Muskie bites. Awe, still, but awe, starting to curdle at the edges into something closer to unease about a machine this hungry, this expensive, chewing through a landscape that regulators were increasingly determined to protect. The math kept working against it. Electricity rates climbed nearly every year through the 1980s, and a machine that already burned tens of thousands of dollars an hour in power had nowhere to hide from a rising bill. Meanwhile, the market for the coal it uncovered kept shrinking. People who had spent years around the machine, mechanics, oilers, men who watched every gear and cable up close, started saying out loud what the ledger already knew in private. This machine had simply gotten too big for its own good, chewing through maintenance hours nearly as fast as it chewed through earth, at a scale that made every repair a production of its own. We still have not answered the real question sitting under all of this. How does a machine that once looked unstoppable end up gutted for scrap? Part of the answer is that tightening budgets never stay confined to a spreadsheet. When a machine this size starts bleeding money every hour, the easiest place to claw some back is maintenance, and maintenance deferred on a dragline is never free. Inspections that used to happen every shift started stretching to every other one. Cable got pushed a little further past its safe service life before anyone signed off on replacing it. None of that showed up as a headline. It showed up as risk, quietly stacking on risk, on a machine already working at the edge of what its drivetrain was built to handle. Then came 1990, and the amendments to the Clean Air Act that finally closed the door. The new law built a nationwide system requiring power plants to hold permits for every ton of sulfur dioxide they released, and it rewarded utilities that switched to cleaner burning fuel with allowances they could bank or sell. Overnight, high-sulfur coal stopped being merely less desirable and became something closer to a direct financial penalty for whoever kept burning it. Tighter limits on sulfur dioxide emissions gutted what remained of the demand for high-sulfur Ohio coal almost overnight. Central Ohio coal now faced a machine that cost tens of thousands of dollars an hour to run, uncovering a product fewer and fewer buyers wanted at the volume this dragline was built to deliver. The economics that had justified $25 million in 1969 simply did not exist anymore in 1991. Keep paying to feed a machine this size, or shut it down. There was no third option on the table. Even if Central Ohio Coal had wanted to keep running Big Muskie at a loss, for sentiment's sake, the rest of the industry had already moved on without it. By the early 1990s, the handful of American coal companies, still stripping surface ground, had shifted towards smaller, newer machines that cost a fraction as much to run per cubic yard moved. A machine built to be the biggest possible answer to a 1966 problem was now the most expensive way available to solve a 1991 problem. Bigger had stopped being an advantage. It had become the whole liability. Late in 1991, the crew brought Big Muskie in for what none of them said out loud would be the last time. The boom came down to rest. The drag cable went slack. The operator's hands came off the controls, and for the first time in 22 years, the machine sat through a full shift without moving an ounce of earth. Dave Bailey was there for it, on shift until the machine's very last operating day, closing out a decade of his working life, inside a machine that suddenly had nowhere left to go. Central Ohio Coal did not scrap it right away. Nobody wanted to make that decision permanent while there was still a chance, however thin, that someone somewhere might want a 27 million pound dragline. That thin chance was about to run out completely, and it would take 8 more years for the company to admit it. Where the beast went. 8 years is a long time for a 27 million pound machine to stand perfectly still, waiting for a phone call that was never going to come. For 8 years, nothing moved. Grass crept up around the base of those 2 enormous shoes. Rust bloomed along cable housings that used to get greased every shift. The cab where an operator once worked levers with total focus sat empty, its windows fogging and clearing with every Ohio season, while 13,800 volts that once fed that trailing cable stayed switched off at the source. A machine that had never once, in 22 years, gone more than a few hours without a human hand on it, now went years without anyone climbing inside at all. After the shutdown, Central Ohio Coal quietly explored selling Big Muskie to another mining operation, but the search ran into the same wall the machine had been built to solve in the first place. Its whole purpose only made sense on ground exactly like the one it stood on. The only large-scale strip operations left in the world that might have suited a dragline this size sat across the ocean, in Germany's Garzweiler Basin, and even there, more efficient bucket wheel excavators had already made machines like Big Muskie obsolete, tearing through overburden at a fraction of the power cost. Moving it anywhere, even if a buyer existed, would have meant dismantling a machine that took 2 years and 200,000 man-hours to build, then somehow re-erecting it somewhere else, at a cost that dwarfed what it would ever earn back. By 1999, the decision stopped being optional. The state of Ohio and the Federal Environmental Protection Agency began enforcing the Surface Mining Control and Reclamation Act, which required idle mining equipment to be removed so the land underneath could finally be reclaimed. Every month of delay risked fines running into the millions, on top of a machine that was already costing money simply by existing, unused, on land the company needed back. On January 13, 1999, Central Ohio Coal signed the contract, not to move Big Muskie, to destroy it, on site where it had stood since the day it was born. There had been a real push, before that contract was signed, to save it instead. Enthusiasts, local historians, and former crew members lobbied to have Big Muskie preserved whole, turned into a museum piece, the way some retired locomotives and battleships get a second life as monuments people can walk through. It was a fair pitch. This was, after all, a machine that had already survived 1 dedication ceremony and a marching band. But preserving 27 million pounds of steel costs real money too. Money for a permanent foundation, money for ongoing maintenance, money nobody in 1999 was willing to commit to a machine that had already sat idle and unprofitable for 8 straight years. The museum idea died quietly, the same way most good intentions do when somebody finally has to write the check. Torch crews arrived not long after and began cutting into the same lattice steel that welders had spent 2 winters assembling 3 decades earlier. Where construction had taken 2 years and 200,000 man-hours, 1 plate and 1 gusset at a time, the scrapping ran in months. Sparks instead of welds, steel coming apart in the reverse order it had gone together, boom sections lowered instead of raised, motor housings pulled instead of bolted in. By the time the crews finished, Bucyrus Erie's 27 million pound monster, the machine that had cost $25 million to build in 1969, money sold for scrap at $700,000, less than 3% of its original price, for a machine whose replacement cost, in today's terms, would run well past $200 million. Only one piece survived intact. The 220 cubic yard bucket. All 240 tons of it. The same bucket that once held 2 Greyhound buses side by side. The same bucket the Morgan High School band stood inside for a photograph back in 1969. It was hauled to a plot of reclaimed ground near McConnellsville that became Miners Memorial Park, inside what is now Jesse Owens State Park, and set down as the only physical trace left of a machine that once ate a mountain a week. A Caterpillar bulldozer fits inside it today, parked there for scale, so visitors can understand a size photographs never quite capture. 50 years after that first ceremony, in 2019, the Morgan High School band returned and formed up inside the same bucket one more time, closing a circle nobody had planned when they first climbed in as teenagers. The park that grew up around that bucket traces the whole history of Central Ohio Coal Company, with a wall listing every employee who ever worked there and a memorial honoring the miners who never made it home. An entire working life's worth of memory standing at the center of a field simply because nothing else that size was left standing to take its place. Dave Bailey still lives near McConnellsville today. "I was on it until the very last day it operated," he says now, and there is a particular kind of quiet in a sentence like that. From a man who gave a full decade of his working life to a machine that once demanded 2/3 the power of Las Vegas and now demands nothing at all. People still ask him about those years constantly, and he says he never gets tired of answering, because the memory of tending that machine clearly never let go of him either. There is a particular kind of loneliness in that. A machine that once needed 7 men around the clock, 364 days a year, now needs nobody at all. No operator working the levers through a long night shift. No electrician tracing a fault through 13,800 volts of wiring by flashlight. Just a bucket, a plaque, and whatever a visitor already happens to know walking up to it. The land itself outlived the machine in a way nobody at that 1969 dedication could have predicted. 10,000 acres of the ground Big Muskie stripped bare were reclaimed and became the Wilds, a wildlife conservation park where rhinoceroses, giraffes, and zebras now graze across hills a dragline once tore open for coal. Much of the rest of the old mine property became parkland, bearing Jesse Owens' name. Where a machine once moved earth by the hundreds of millions of tons, animals from 3 continents now move across restored grassland that remembers almost nothing of what stood there. 200,000 man-hours went into building Big Muskie. A torch, a federal permit, and 8 years nobody wanted to pay for is what it took to end it. Somewhere outside McConnellsville, Ohio, a single bucket sits quiet in a field where a monster used to stand. And every summer, strangers climb inside it, stand where a marching band once stood, and try to imagine the rest of a machine that simply got too big to survive, being small enough to need.